Hello, welcome back. Today we're going to do some good old-fashioned geometry. This is chapter 2. I think there's a test coming up pretty soon here. So this is kind of going to be our final project, so to speak. This was an extra credit problem at one point, and Mr. Colander said it was one of the hardest ones. So if you did it before, good for you. But I'm just going to go through all the steps that we could use to get here, plus some other stuff. Here you can get a little spoiler on what we're going to do. But I'm going to start with Theorems 4 through 7, which is these ones here. These get a little confusing, you know. Sub to same angle, sub to congruent angles, comp to same angle, comp to congruent angles. The important thing is that when you finish these, the conclusion is always, then they are congruent. If you do this in the proof, like prove angle A is sub to angle B, you can't do that. The proof has to be that they are congruent. Like, it has to be that angle A is congruent to angle B. And if you're going to do this, that would probably be like def sup, if that makes sense. Anyway, all of that really just to say, when you need to do a congruency thing like this, the important thing to note is when you have something like this where it's to congruent angles, that means you're going to see something like this. You're going to have the two sups and then the congruency. So if B and D are congruent, really, like if we're just calling this blue, now they're both blue. Sorry, it's kind of a funny way to do it. Then that means that angle A and angle C are both congruent to blue, and if blue is congruent, then angle A is congruent to angle C. And that's for congruent angles. If it's for a same angle, then it just means angle A is congruent, angle A is sup to angle B, and angle C is sup angle B. And since they're both the same, that means that A and C are congruent. Does that make sense? I don't know. I'm saying, does that make sense to a camera? I don't really know. Anyway, that's theorems 4 through 7. So just remember using the right one, that it's same or congruent. Same is only if they're literally the same, like if they're actually the same angle. Congruent is if there's a third thing like that in the given. Hopefully that made sense. And then let's talk about transitive and substitution. Now, transitive and substitution aren't the same thing. Maybe you're saying, obviously they're not the same thing. What's even the difference? The real big difference is transitive is always congruent. Like if A, B are congruent, and B, C are congruent, then A and C are congruent. And so that's like the algebra equivalent of an equal sign. So like if A equals B and B equals C, C equals A. But for substitution, it can't be congruency or equals. That's saying like you're putting in a different thing, like supplementary, complementary, or just anything else. So it's like the equivalent of saying like 2x plus 4 equals 8 and x equals 2. That's substitution. You're substituting this in to a different like phrase, so to speak. So this would be like the phrase, and this is the substitution. So just remember that transitive is always a bunch of congruent signs. So it's going to be like 3, maybe less, maybe more. I don't know. I think it usually would be 3. And then substitution is like anything else. So that's just your little review on that. And then let's start talking about multiplication, division, addition, and subtraction. So this is for addition and subtraction. The important thing to remember is that addition and subtraction, oh, sorry, getting my things confused. Addition and subtraction have the same part. I'm struggling to write. So the same part in this case is this line segment BC. So we know that AC and BD are the same, and then this part is like a common thing in both of them. Sorry, I'm not really wording well today. If we subtract the BC from AC and the BC from BD, then it would be the same because this is the same line segment. So this is subtraction. And if you're confused between addition and subtraction here, basically just if it's getting to be smaller, so like from going from AC to AB, like this, like the AC to AB, if it's getting smaller, then that's subtraction. If it's getting bigger, like let's just say if the proof was the opposite, like prove AC is congruent to BD. Basically, we switch the given and the proof around, I guess is what I'm saying. Then that would be addition. So hopefully that made sense as well. And then here's the thing with multiplication and division. This is an example of multiplication and division. Like Mr. Colander said, a good indicator is the double bisection or trisection, and then a congruency. So even if the congruency isn't in the actual given, if you somehow, in one step or another, prove that there's another congruency, then and the double bisection, then that's multiplication or division. So to figure out the difference between those two, you're seeing, is it these bigger angles or is it smaller angles that you're trying to find? So in this case, angle bad here. See what I did there? Anyway, angle bad here is being bisected, and we're trying to prove 1 and 2 are congruent. 1 and 2 are smaller than bad and YXZ. So that would be a case of division. The reason this works is if you know that these are congruent and you know that these are being bisected, then you know that the bisections that they make, so like this angle and this angle, that they're all the same. So you're dividing them to be all the same. And in this case, you know, as per usual, if there's a labeled one, like a 1 or a 2, that's important. In this case, it's the 1 and the 2 that you're trying to find, so you could just call this division. Ooh, sorry. And the important thing to remember between this and this is that the addition and subtraction is always going to be, is always going to be the same part. In this case, they're not the actual same parts that you're subtracting. You're subtracting like a whole different angle. So like these whole different angles, it's not the same part like this BC here. If that makes any sense to you, like they're whole different thing, you know. And then just real quick go over vertical angles. This also will be transitive, but vertical angles, it just means if you have a thingy like this, that these ones are the same and these ones are the same. But since the numbers are on those ones, we'll just focus on 1 and 2. So what we know right now is that 1 and 4 are the same. These are congruent. And we know that if it's a vertical angle, then these will be the same. So we can say that angle 1 is congruent to angle 2. Angle 3 is congruent to angle 4. And you see all these congruencies here? That means you can do transitive. That's kind of a weird abbreviation, sorry. Anyway, so you can say that if 1 and 4 are the same thing, then you can just swap those out and say that angle 2 is congruent to angle 3. And that would be your proof. So I think that one would be a 3-step proof, just by the way. I'm not actually doing the columns yet. And then here is our final one. This was the extra credit proof that I mentioned, and it is a little tricky. I think in the end it'll have like 6 steps, but it's important to know how to do all these things. So, the very first thing I want you to notice is it doesn't say it. It doesn't always say it, but there is a straight line in this diagram, and there are angles that look like this in the diagram. So the first thing you should be checking for is, will I need to assume something? And the answer in this case is yes. So your first step, you know, you have the given, which is just that stuff. And then the next thing will be XPY, we can just call it. Angle XPY is straight. And that's assumed. Sorry, my handwriting is terrible. This is not a very great system. Whatever. So we know that this is straight. And then what's the next thing we know? We know that angle 1 and angle 2 are congruent. And we know that this angle here and this here, let me grab a different color. And this angle here are supplementary to each other because this line is straight. So one of the next things that we can say is that angle 1 is sup to, well, you don't really have to put the 2. I'm just going to do that to save space. And then angle 1 sup to APN. Angle APN. Angle 2 sup, sup angle ANP. So now, and this would be, sorry, let me move this over here. This would be def sup. Just because we're saying, it's a pretty obvious, I don't know about obvious, but it's a pretty obvious assumption to say here. And I'm kind of covering stuff up, sorry, but this is a 5 and a 6. 5 and a 6. So, what we can say with that is that this is 2 supplementaries, and we know that angle 1 and angle 2, still getting used to this. Angle 1 and angle 2 are congruent. So if we know that these are congruent, then we can just like say that these are the same. And that means these are sup to congruent angles. So you can say that APN is congruent to ANP. And that would be sup to congruent angles. Now we're getting somewhere. So we know that PE bisects APN and NE bisects ANP. And we know that these ones are congruent. So if this bisects this and this bisects this, what does that tell us about all the rest of the angles? Well, that means that 3, 4, 5, and 6 are all going to be the same. And that's pretty obvious to you and me. But the question is, how do we know that? So we said that angle 3 congruent to angle 4, congruent to angle 5, congruent to angle 6. And you're not going to need to use all of these. But you can tell, because if these ones, if A, P, N are the same, and A and P are the same, and they're both getting bisected, that means that all of these are going to be the same. And if you remember from before, if you have a double bisection and congruency, that means it's multiplication or division. And because we're going from a bigger angle to a smaller angle, so like this big angle to this small angle, that would make that division. So now we know that 3, 4, 5, and 6 are all the same. Sorry, this is getting kind of messy over here. I'm going to start changing colors so you can actually see what I'm drawing. Now we got to look at this part finally. XPE and NEY, or ENY, sorry. XPE is this one here, and ENY. What do you notice about these? Well, it's this angle 5 plus angle 2, and this angle 3 plus angle 1. We know that 1 and 2 are congruent, because that was in the given here. And we know that 3 and 5 are congruent, and those are going to be the important ones in this case. So all we really need to know is this. Here, I'll just rewrite. Angle 3 is congruent to angle 5. And that was still our division. So really all we need to do now is say that angle XPE is congruent to angle ENY. So why exactly can we do that? Because we can just say if these are congruent, and if these are congruent, and we just add them together, then that means the whole big angle is congruent. So you're going from 2 small angles to a big angle, and that would be addition. And that was all of it. So a 6-step proof. The first one was assume, and of course given. So these are 6 steps of this proof. Hopefully that made sense to you. Got a little messy over here. But basically the idea is we were able to use def sup, subcongruent angles, division, addition, which are all pretty weird and difficult ones to use. And I think that's basically all I have for you. If you have any more questions about any of this, or if you want me to go through any certain other problems, feel free to let me know. But as for now, that is all. I will see you next time.